Hello, welcome to part 2 of Complex Numbers, section 1.3. We're going to pick up where we left off last time. The next thing we're going to do is add complex numbers. This could not be easier. It feels exactly the same as combining like terms, so really all we have to do is add the real parts together and add the imaginary parts together, and that's the extent of it. And when you want to subtract complex numbers, just make sure and distribute the negative sign that's in front of your second complex number, and then you can go ahead, add the real parts, add the imaginary parts. And we're going to add these together, and notice it says write answers in standard form, so that's that A plus BI format. Okay, all we have to do is real part added to real part, so 3 plus negative 2 will be 1. And then imaginary to imaginary, so negative 4i plus 6i adds up to positive 2i. And that's all that there is to it. On this second one, we have a subtraction, so let's distribute the minus sign. So that's going to become plus negative 6 plus 7i. So I distributed it, or what I did was what you probably learned back in middle school. I changed the minus to a plus, and I changed the sign of every number in here. Either way you want to write it, it's fine. Now, let's combine real plus real, so negative 4 plus negative 6 will be negative 10, and then 3i plus 7i is 10i, and that's all we can do there. And here is a similar exercise, a couple of them, and so I hope that you will pause the video and try these on your own before we look at them together. And now that you've tried them on your own, let's combine real plus real, so 3 plus 9 is 12, and 2i minus 3i is minus 1i, so we have 12 minus I. And here, negative 2 plus 4i minus negative 4 plus 4i, let's distribute the minus sign. So it's going to become negative 2 plus 4i plus 4 minus 4i. Now we'll combine real with real. Negative 2 plus 4 is 2. And imaginary with imaginary. Notice that in this case the imaginary parts add up to 0, so it's not necessary to write anything else. 2 plus 0i is really just the same as 2. Okay, now let's multiply two complex numbers. And when you multiply, you're really doing a binomial times a binomial, so we will use the FOIL method that you remember from when you first learned to multiply binomials together. So when we do this, remember that I squared is the same as negative 1, so we'll always simplify any I squared away at the end. Okay, here we have a few complex numbers to multiply together, and so we'll be thinking about the FOIL method as we do this. First times first here is going to be 6. Outer times outer is 2 times 4i, so that's going to be plus 8i. Inner times inner is going to be minus 3i times 3, so that's minus 9i. And then last times last is going to be minus 12i squared. Now we'll combine like terms here with our i's, and we'll simplify I squared. So we've got 6, and then 8i minus 9i becomes minus 1i, and then minus 12 times I squared becomes minus 12 times negative 1. Remember, always I squared simplifies to negative 1. So now we have 6 minus I minus 12 times negative 1, so negative 12 times negative 1 is going to become positive 12. And then we can combine like terms at the end. So 6 plus 12 is 18, and then we have our minus I hanging on there. Here's a squared complex number. This is going to be 4 plus 3i squared, so we can write that out as 4 plus 3i times itself. First times first is going to be 16. Outer times outer is going to be 12i. Inner times inner is also 12i, and that's not a coincidence. That happened because we were squaring this binomial. And so if you're not doing a show work problem on a quiz or a proctored test, you could kind of take a shortcut here and just mentally say, you know that outer and inner are both going to be 12i, so your middle term you know is going to be 24i. You could take that shortcut if you wanted to, as long as you're not on a show work problem. And then at the end, last times last is 3i times 3i. So that's going to be 9i squared. And remember, I squared is negative 1. So we'll combine terms here and we'll change our I squared to negative 1. We'll have 16 plus 24i, and then plus 9i squared makes 9 times negative 1. And let's combine our negative 9 with our positive 16 here. And 16 minus 9 is going to be 7. And then we've got our plus 24i. In our last example for this page, we have 6 plus 5i times 6 minus 5i. Notice that these are the same two terms, only the difference is the signs between them. So this is called a sum and a difference of the same two terms. These are also called complex conjugates because one is 6 plus 5i, the other is 6 minus 5i. And a conjugate is when you have the same two terms but just a different sign in between. So we're going to see something interesting that happens when we multiply a complex number times its conjugate. Here we go. FOIL method. First times first will be 36. Outer times outer will be minus 30i. Inner times inner will be plus 30i. And last times last will be minus 25i squared. Okay, now of course I squared is going to become negative 1. But look what's going to happen to our I terms here. Negative 30i plus 30i, those are going to add up to 0. And so our final result is 36 minus 25 times negative 1. Our I squared has turned to negative 1. Now minus 25 times minus 1 is going to make plus 25. And then we can add these together. 36 plus 25 is 61. So this is interesting now. We multiplied together two complex numbers and we got a purely real number that does not have an imaginary part. Or another way to say it is, you could say its imaginary part is 0. And this is going to happen every time we multiply a complex number times its conjugate. So watch for that and just know in advance that you're going to end up with a real number. Okay, here are a few practice problems. I hope you'll pause the video and try these on your own before we go through them together. And now let's go through them together. So first times first is 6. Outer times outer is minus 4i. Inner times inner is going to be plus 3i. And last times last is going to be minus 2i squared. Now on this one we'll take a shortcut and we'll, instead of writing out that I squared is negative 1, let's just mentally do it. So we know that now negative 4i plus 3i is going to make minus 1i. And then negative 2 times negative 1 is going to make positive 2. And then combine your real numbers. 6 plus 2 is 8. So we have 8 minus I. On this second one, it's like the squared complex number that we had on the last slide. We've got 3 minus 2i squared. So let's write it out times itself. Now first times first is going to be 9. Outer times outer is going to be minus 6i. Inner times inner is the same thing. And then last times last is going to be plus 4i squared. And now these middle terms will not cancel each other out because they are the same sign. So we're going to end up with 9 minus 12i. Negative 6 minus 6 is minus 12. And then the 4 times I squared is going to make 4 times negative 1, which is minus 4. Alright, now combining the real parts, 9 minus 4 makes 5. So we have 5 minus 12i. Okay, now our last example for this page, we've got negative 2 minus 3i times negative 2 plus 3i. And notice that this is a sum and a difference of the same two terms. So we know before we start that our middle terms are going to end up canceling each other and we're going to come up with an answer that's a purely real number. And so here we go. Negative 2 times negative 2 is positive 4. Outer times outer is going to be minus 6i. Inner times inner is going to be minus 3i times minus 2. It's going to be plus 6i. and last times last is going to be minus 9i squared. So negative 3 times positive 3 is minus 9, and then I times I is I squared. Okay, now let's go back and combine our imaginary parts here. So I've got 4 minus 6i plus 6i adds up to 0i, so I won't even have an I term. And then the I squared is negative 1. So minus 9i squared is minus 9 times negative 1, which is positive 9. And then, of course, 4 plus 9 is 13. Okay, now again, we talked about this a little bit, but 6 plus 5i times 6 minus 5i that we saw in the previous slide, those were called conjugates. Conjugates differ only by the middle sign, and multiplying conjugates together always gives a real answer. Now here are a few examples for us to practice dividing with. It says find each quotient. We are in fact dividing complex numbers, and we're going to write each answer in standard form, but it is not going to feel like dividing because you're not going to see any dividing going on. What you're going to see is that we're going to multiply by the conjugate of the denominator, because even though it's called dividing, the real goal of this is to get a real number in the denominator so that we can write it in standard form. And the only way to get a real number down here is to multiply by the conjugate of the denominator. So here we are multiplying by the conjugate of the denominator, and whatever we do to the bottom we have to also do to the top, so that effectively we're just multiplying by 1. And now here we go with the FOIL method in the top. First times first is 15. Outer times outer is plus 3i. Inner times inner is plus 10i. And last times last is going to be plus 2i squared. Alright, now in the denominator, 5 times 5 is 25. The outer and the inner will add up to 0. That's the entire point of multiplying by a conjugate. So let's not even bother to write that down because we know they have to make 0. And then last times last is going to be minus I squared. Okay, now combining like terms in the top, 3i plus 10i is going to make 13i. The I squared here is going to simplify to negative 1. So we have 2 times negative 1, which is minus 2. Now in the denominator, minus I squared becomes minus negative 1. So that's going to be written as 25 plus 1. And now combining like terms, 15 minus 2 is 13. And then plus 13i, and in the denominator, 26. Okay, the division is now done, and all that's left is for us to write this in standard form. So we'll need to split it into 2 parts. Each part will have a denominator of 26, and then we reduce each part. 13 over 26 reduces to 1/2, and 13i over 26 reduces to 1/2 I. Okay, so that's that one. And now this one is a little simpler, believe it or not. We have 3 over I. There's no conjugate necessary here, so all we have to do is multiply top and bottom by I itself. So that's going to give us 3i in the top and I squared in the bottom, which we know is negative 1. And 3i divided by negative 1 would just be negative 3i. And here are a couple of practice problems that are similar to the 2 we just did together. So I hope you'll pause the video here and try these 2 on your own. And now let's go through these 2 together. So we have here, it says find each quotient. We have 6 plus 2i over 1 plus 2i. And when we find a quotient of complex numbers, what we're really trying to do is get a real number in the denominator, and we can do that if we multiply by the conjugate of the denominator, so the denominator comes up real. So the conjugate of 1 plus 2i is going to be 1 minus 2i. I need to do that in the top and the bottom so that what I'm really effectively doing is multiplying by 1. Okay, now here we go with FOIL method in the top. First times first is going to be 6. Outer times outer is going to be minus 12i. Inner times inner is going to be plus 2i. and last times last is going to be minus 4i squared. And then in the denominator, first times first is 1. The outer and the inner will cancel out, so why not just skip that? Those should add up to 0. They must add up to 0. And then last times last is going to be minus 4i squared. Okay, now combining like terms in the top, our negative 12i plus 2i is going to add up to negative 10i. And then our I squared here is going to be negative 4 times negative 1, so that's going to be positive 4. In the denominator, 4i squared is going to be, well, negative 4i squared is going to be negative 4 times negative 1, which is positive 4. Okay, so now combining like terms again, I have in the top 6 plus 4 is 10, and in the bottom 1 plus 4 is 5. Okay, now the division part is done, and we now want to write our answer in standard form, which means taking this complex number and splitting it into two separate terms, and then simplify each fraction separately. So 10 over 5 is 2, and 10i over 5 is 2i. And now let's look at this one together. Negative 5 over I. Because the denominator is a single term, all we need to do is multiply by I over itself. There's no conjugate necessary here. That's going to give us negative 5i in the top, and I squared in the bottom, which is negative 1. And then negative 5 divided by negative 1 is positive 5, so we end up with positive 5i. Okay, the last thing we want to look at together in this section is simplifying powers of I. So this is actually pretty easy to do because it turns out that powers of I don't keep increasing and increasing like powers of other numbers, but they rotate through a cycle. So powers of I can be simplified using the facts that I squared equals negative 1, which we already knew, and I to the fourth is I squared times I squared, which would be negative 1 times negative 1, which is really just positive 1. So if we always keep these two things in mind, we'll see that it's going to be pretty easy to simplify any power of I that you have. So let's go through a couple of cycles here and you'll see what I'm talking about. Here we have I to the first. Well, that's just I. I squared we already know is negative 1. I to the third can be written as I squared times I, and we already know that I squared is negative 1, so that makes it negative 1 times I. Well, that's just negative I. And then I to the fourth we already know is positive 1. Okay, so look at I to the fifth. I to the fifth can be written as I to the fourth times I, and we know that I to the fourth is 1, so I to the fourth times I is 1 times I, which is just I. I to the sixth can be written as I to the fourth times I squared, which will be negative 1. I to the seventh can be written as I to the fourth times I to the third, which is just going to be negative I. And I to the eighth can be written as I to the fourth times I to the fourth, which is just 1. So you see the pattern here. It goes from I to negative 1 to negative I to positive 1, and then it goes back through the cycle. And if you go up another 4 powers, you'll go back through the same cycle again. So since I to the fourth is 1, we can determine the value of a power of I by separating the exponent into a multiple of 4 and a remainder. And you see that's exactly what I did here. For each of these powers that was greater than 4, I pulled out the I to the fourth and I could see what was left. So let's practice this idea together just a little bit. We'll simplify each power of I. Okay, so this first one says I to the 15th power. And we want to think to ourselves, what is a multiple of 4 that's less than 15? Because if we can separate this I to the 15th into some multiple of 4 times whatever other power is required, it'll be easy to simplify. Well, 12 is the largest multiple of 4 that's less than 15. So I'll separate this into I to the 12th times I to the third. Now the benefit here is that anytime our exponent of I is a multiple of 4, then this quantity is just going to be 1, because we know I to the 4th equals positive 1. So I to the 12th is going to be I to the 4th times I to the 4th times I to the 4th, so which is 1 times 1 times 1. And so this quantity here is just 1. So what we have now is 1 times, from the previous slide, we know this is going to be negative I. And so 1 times negative I is just negative I. Okay, now let's try it on part B, which is a negative power. So it would be much easier for us if the power were positive. So the trick here is to think about the absolute value of negative 3, is positive 3, and think of a multiple of 4 that's more than positive 3. Well, it would be positive 4. So what I'm going to do is multiply this quantity by I to the positive 4th, because that way when I add my exponents together, negative 3 plus 4 will come up positive 1, and that way I can simplify that power. So I to the 1st is just I. And let's try it again. So here we have I to the positive 25th power. So I want to think of a multiple of 4 that's less than 25. Well, 24 comes to mind. And what power would be required to complete the 25th power here? Well, 24 plus 1 is 25. Okay, now any I power that's a multiple of 4 is going to just simplify to positive 1. So here I have positive 1 times I to the 1st, which is just going to be I to the 1st, which is just I. And that's all that needs to be done to that one. And let's try this last one together. So I to the negative 13th. Think about the absolute value of negative 13 is positive 13. And now think about what is a multiple of 4 that's bigger than 13. Well, 16 is a multiple of 4 that's bigger than 13. So let's multiply I to the negative 13th times I to the 16th, because you know, since this is a multiple of 4 exponent, I to this power is just a big positive 1. And now we can add exponents. Negative 13 plus 16 is positive 3, and we know from the previous slide that I to the 3rd is negative I. Okay, now this has been a pretty long section. If you think back over all the things we've done, we have simplified radicals with negative radicands. We have added and subtracted complex numbers. We have multiplied complex numbers, and we have divided complex numbers, and now we have simplified powers of I. So there's a lot going on in this section. I hope that you'll spend some time practice in my math lab, ask questions, review your notes, give yourself time to think about things and work back through all of the things that we've done together, because it takes time for your brain to assimilate all of this. And just keep practicing and don't give up. It's nothing that you can't handle, but you just have to give yourself time to work on it. Good luck. Reach out to your instructor if we can help you.